If you're prepping for exams, you know neuroanatomy can feel like trying to memorize a map of a city you've never even visited. Well, today, we're going to change that. Welcome to Visual DepictsMED. We're taking a clinical tour of the lateral ventricles, and we're focusing only on the high-yield connections you absolutely need to know to ace your questions. Let's jump right in.
So, here's our game plan for today. We'll start with the big picture. Then we're going to take a journey along that famous C shape through the brain. We'll explore the anterior horn, the central part, the posterior horn, and finally, the inferior horn. And stick around, because at the end, we're going to do a quick-fire clinical review to make sure all these concepts are locked in for exam day.
All right, first things first. What exactly are we looking at? Well, I want you to imagine that your brain has its own internal reservoir and canal system. That's pretty much what the ventricular system is. And the lateral ventricles? They're the two biggest, C-shaped reservoirs, nestled deep inside each of your cerebral hemispheres.
And this view right here really shows off that classic C shape, doesn't it? Now, these are not just empty spaces. They are filled with cerebrospinal fluid, or CSF. And you can think of CSF as the brain's personal life support system. It's a shock absorber, it delivers nutrients, and it clears out all the waste. It's literally the reason your brain can float safely inside your skull.
So to recap, we've got two of these C-shaped structures, one in each hemisphere. And to make sense of them, we break each one down into four parts that just follow that curve. You've got the anterior horn pointing towards the front, the central part, which is also called the body, the posterior horn sweeping back, and the inferior horn, which hooks down towards the base of the brain.
So you might be asking, why on earth do we have to memorize all this architecture for exams and for the clinic? Well, here's why. On a brain scan, the size and shape of these ventricles, they tell a story. If there's a blockage somewhere in the system, CSF can back up and cause these chambers to swell up like a balloon, a condition we call hydrocephalus. And seeing that enlargement on an MRI can point you directly to the problem. It's a huge clinical clue.
Okay, let's start our tour at the very front of the train, with the anterior horn. And as the name suggests, it extends right into the frontal lobe.
And there it is, extending forward from this really critical choke point, the interventricular foramen, which you'll also hear called the foramen of Monro. Just think of this foramen as the little doorway that connects the lateral ventricles to the next chamber in the system, which is the third ventricle. Okay, time for some high-yield anatomy, the bounders. Let's think of the anterior horn as a room. The front wall and the ceiling are both made from parts of that massive structure, the corpus callosum, specifically the genu at the very front and the trunk right on top. The floor is the smooth, rounded head of the caudate nucleus, and the medial wall, the one separating it from its twin on the other side, that's a thin little sheet called the septum pellucidum. So a really simple way to remember it, the giant corpus callosum just wraps around the front and top of this horn.
So what's the clinical pearl here? It's all about location. If the anterior horn enlarges, what's it going to press on? The frontal lobe, right? This can lead to those classic frontal lobe signs you'll see in patients. Things like major personality changes, trouble with planning, and what we call executive dysfunction.
All right, let's move backward from that foramen into the central part, or the body of the ventricle. The key relationship to burn into your brain here is its location. It sits directly on top of the thalamus.
Okay, so once again, the corpus callosum is making up the roof. But the floor, oh yeah, the floor is where things get really interesting. And it is a classic exam topic. Let's walk through the structures on the floor from the outside in. So from lateral to medial, you have the caudate nucleus, then the stria terminalis, then the thalamostriate vein, and finally the thalamus. A fantastic way to remember that order is the mnemonic, cars sometimes try things. And for the medial wall, you've got the septum pellucidum and the fornix.
And this just perfectly illustrates the clinical importance. The thalamus is like the great relay station for the entire brain. So you can imagine, a hemorrhage from a nearby vessel or any lesion that messes with the floor of this central part can have absolutely devastating consequences for sensation, for consciousness, and for motor control.
All right, let's keep going on our tour. We're now curving backwards into the posterior horn, which, you guessed it, extends right into the occipital lobe, the brain's visual processing center.
So take a look at how the posterior horn curves both backward and inward, sort of toward the midline of the brain. Now here's an interesting clinical tidbit. This is the most variable part of the lateral ventricle. Its size can be wildly different from person to person, and a lot of the time, that's completely normal.
Okay, for the boundaries here, the roof and the lateral wall are lined by this, well, it's like a carpet of fibers from the corpus callosum called the tapetum.
Now you really got to pay attention to the medial wall. This is an exam favorite. It's got 2 bumps on it. The upper bulge is called the bulb, and it's created by fibers called the forceps major. The lower bulge, the calcar aves, is even more important. It's caused by the calcarine sulcus pushing inward, and that sulcus is the key landmark for your primary visual cortex.
So here's the clinical tie-in. That tapetum we just mentioned, that carpet of fibers, it separates the posterior horn from a super important pathway called the optic radiation. These are the fibers carrying visual information to the cortex. So if the posterior horn expands for any reason, it can compress these fibers and cause very specific visual field defects.
And finally, we're going to follow the C shape as it curves down and forward right into the temporal lobe, forming the inferior horn. This is a region that is critically involved in memory, so you're going to want to lock in for this last part.
Here's one of those precise details that's just perfect for an exam question. The inferior horn extends to within about 2.5 centimeters of the temporal pole, ending just behind a structure called the uncus. So remember that number, 2.5 centimeters.
The roof, once again, is formed by that tapetum from the corpus callosum. But the floor, well, the floor is arguably the most clinically important structure we are going to discuss today. Laterally, we have something called the collateral eminence, but medially, and this is the absolute key takeaway, we have the hippocampus. And here is why that matters so much. The hippocampus is absolutely essential for forming new memories. Now, in Alzheimer's disease, the hippocampus atrophies, which means it shrinks. As it shrinks, the space it used to take up gets filled by CSF, causing the inferior horn to get bigger. This enlargement is one of the classic diagnostic signs we look for on an MRI of a patient we suspect has Alzheimer's.
Okay, we have officially completed our tour. Now it is time for a rapid-fire review to lock in these high-yield facts before you walk into that exam room.
Here it is, all in a nutshell. When you see anterior horn, I want you to think frontal lobe, executive function. For the central part, think of its floor and the thalamus, which affects sensation and motor control. For the posterior horn, think occipital lobe and vision. And for the inferior horn, always connected to the temporal lobe, the hippocampus, and memory.
I really want to leave you with this thought. The absolute key to understanding clinical neuroanatomy is to never just see a space like a ventricle. You have to see its neighbors, the critical brain structures that are forming its walls, its floor, and its roof. And you have to understand what those neighbors do. That is where all the clinical magic happens.
I really hope this tour helped make the architecture of the lateral ventricles feel a little less intimidating. If you found this helpful, do me a favor, hit that like button and subscribe to Visual DepictsMED for more guides just like this to help you crush your exams. Thanks for watching and happy studying.